In this 3-hour long Data Engineering Masterclass, you will learn data engineering workflow, OLTP OLAP databases, ETL, data warehouse and its layers, incremental loading, dimensional modeling, data lake, data warehouse, lakehouse, delta format, column-based and row-based file formats, big data frameworks, cloud data engineering, distributed data engineering with Apache Spark, Azure data engineering tools and technologies, Medallion architecture, and much more. But why you should watch this video? Well, the demand for data engineers are growing rapidly, and if you also want to become a part of this domain, and if you are already a business analyst, data analyst, or a complete beginner, this video is for you because you will learn each and every concept from scratch. Not just this, you can expect at least 50% of your interview questions will be covered from these fundamental areas. Take out your notebooks, pen, pencil, highlighters, everything, and just start taking notes because we are getting started with this Data Engineering Masterclass. Welcome, welcome, welcome. Welcome to the Masterclass of Fundamentals of Data Engineering. So, this video is for you only if you have some excitement, if you have some passion to become a data engineer. Because in this particular video, we will be covering everything from scratch. So you do not need to have any prior experience. You just need to have some excitement and some curiosity to know the concepts that we have in the world of data engineering. Why this video is for you? Because you want to enter data engineering domain, or you just want to excel as a data engineer if you are already a data engineer, because it's possible that you are a data engineer but still you are not familiar with all the fundamental concepts. Or if you are already familiar, it's a great video to revise all those concepts, because not everyone is focusing on the fundamentals right now. Everyone is just running after tools and technologies. And let me tell you one thing, in your data engineering interviews, 50% of the questions will be covering just from the fundamentals. So it's really important area. And after covering this, let me tell you, once you complete this video, once you watch each and every section with focus, you will be so confident to learn any new tool and technology, because tools may come and go, but fundamentals remain the same. Yes. So just put your notebooks on your table, pull out your pencils, pen, eraser, highlighters, and just start taking notes, because we are covering everything from scratch. So without wasting any time, let's get started. So first of all, the favorite question, what is data engineering? This is the first question that you have in your mind right now. Like what exactly is data engineering? Because we do not know anything. We do not even know D of data engineering. We want to know everything. Okay, so let's discuss it. And obviously the follow-up question, why do we need data engineers? Oh, that's a really good question. By the way, companies are running after data engineers. So this question can give you some highlight that we do need data engineers, but why? So everything will be answered shortly. First of all, what is data engineering? So if you go on Google and or any search engine, if you just type what is data engineering, you will see thousands of definitions, and I'm not lying. I'm not lying. You can just try it right now as well. So does that mean that we do not have any standard definition of data engineering? Yes or no, but still, let me give you the definition that I follow, or you can say that a kind of standardized definition that we have. So what's that? So the thing is, data engineering is taking the data. Let's say this is some data. Just forget about like what is written here, SQL, nothing. No, this is some data, right? And this is really raw form of data, like really messy data, and no relationships between data sources. We just have data. We just have data. So these are kind of raw ingredients that we have. Then you as a data engineer, okay, so this is a data engineer. So you as a data engineer, what you will be doing, you will refine that data and will deliver that data in the form of data models. This is the kind of definition that you can use. So let me summarize again. So it is a kind of journey. So you will start with the raw. Let me write here. Let's say this is raw data. Then you will just take this data and you will apply some transformations, and then you will serve this data to your stakeholders. Okay, stakeholders. Perfect. So this is a kind of definition that you can use. So if I relate it with any real-time analogy, so you can imagine data engineer as a chef. Yes, you heard it right, a chef, where a chef will receive some kind of vegetables, let's say potato, onion, carrot, so on, and data engineer will take all these raw materials. He will cook those vegetables and serve a nice dish which can be eaten by the stakeholders. Not the stakeholders like obviously the clients or anyone. So you are working as a chef, but in the world of data. So this is the kind of definition that you can use. And now I think this follow-up question is answered, right? Why do we need data engineers? Because if we do not have data engineers, who will serve that data to the stakeholders? Who will just cook the dish, which is a data dish, to our stakeholders? And who are our stakeholders? We will talk about that topic as well very soon. Just hold your breath and just take notes. So data engineering is like taking your data from one place and serving that data to the other place. And while you are doing this serving thing, you are transforming that data as well, so that you can present the best quality of data. Simple. This is the definition. Because you need to understand the concept behind the definition. You do not need to learn the definition. There are like thousands of definitions. If you want to learn, you can just type on Google and just learn it. But that's not the thing. You need to understand the concept, because data engineering is really wide concept. So I hope now you know like what is data engineering, what is D of data engineering, because other alphabets will be covered very soon. And obviously we need data engineers. Why? So as you will see the graph, if I just show you the graph, let's say this is the graph, this is the graph, and the graph really went like this for the demand of data engineers. Why? I have one more graph as well because of that reason. Because the rise of data went like this. Data was rapidly increasing day by day. So they need professionals who can handle that data, and they can just serve that data to the customers. Because with the rise of data, business want to take data driven decisions, and who are responsible for that? Obviously data engineers. So that's why we need data engineers. So this was all about the D of data engineering. Now you know like what is data engineering and why do we need data engineers. Why do you see like lots of job postings for like data engineers and like pay is so high? Because of this thing. Data is everywhere. This is the reason. Okay, so we have learned like what is data engineering. Now let's jump on to the data engineering workflow. So now it's time to actually look at the workflow of the data engineering in detail. So that was the overview, like how things are being done behind the scenes. Now it's time to just look at the overall workflow. Yes. Okay. So in this workflow, we have something called data production. Now, what is this data production? What is this data production? Okay, let me tell you. So data production is a kind of activity where you can say data is generated. Data is being generated. you are doing anything on a mobile phone, data is being generated. Don't worry, we will discuss this particular stage in detail. So for now, we are just covering the workflow. So data production is like when data is generated. It can be like in the form of CSV files. You must be aware of CSV files if you are a data analyst. Or it can be like, you can say SQL databases, or let's say any information, any kind of information can be our data. Let's say you are just searching on Google. I just mentioned that just go on Google and just search what is data engineering. That data is also being generated, that this person has searched this term. That data, yes, that data is also being generated. Like you just go on Google and you just type www dot something, right? That data is also being generated. This is also data. So these all activities come under data production, where data is being generated. With the advent of, you can say, internet, things are going up and up in terms of generating data, because everything is available online. People are going just online to solve their queries, to just buy something, to do any activity. Everyone is going online instead of just physically doing the same thing. Even if you just look at your phone, let's say you are dialing a number, that data is also being generated. You can just validate those things in your maybe monthly phone bills, that this person has made this call. So all of that data is being generated. Now I think you are like being more relatable towards the data engineering and why do we need data engineers. So okay, we understood that we have this much amount of data, massive amount of data. Obviously, data is a garbage. Let me complete. It's not garbage, but if data is not transformed, it is garbage. Why? Let's suppose, as I just mentioned, that we are chef, right? And if you just go to any restaurant and you say like, I'm really hungry, I want to eat something. So what if I will just present some, you can say, raw materials. Let's say I will just give you raw potato and raw carrot, and I will just give you some salt and I will say, okay, consume it. Will you consume it? No. Obviously you can eat it, but it will be really hard to digest it. Really? Yes. So same thing goes here as well. Obviously we have data, we can serve this data, but imagine when we just design this data and we just apply some kind of transformations. Some kind of transformation. What kind of transformation? We will look, just relax. We apply some kind of transformations and then we serve this data in clean and structured format. Just imagine the level of decision making they will have in the businesses. Just imagine this. So this is all about the data engineering workflow, where we have data production, data is being generated, then we have data transformation. We just cook something out of that data. We just make that data usable by the data leaders and they enjoy the meal. They enjoy the meal. That is all about data engineering workflow. So these are the three main pillars of data engineering: data production, data transformation, data serving. These are three main pillars. If anyone asks you what are the three pillars, obviously data production, data transformation, data serving. Yes, these are three pillars that we need to take care of as a data engineer. Okay, so this we understood. Now, as I talked about data production slash data generation, we need to understand this concept in detail because this is one of the main pillars of data engineering. Okay, so as you can see, we have API. Now, what is API? API is nothing. Just forget about it for now. We have a kind of website. Okay. Okay. We have a streaming platform. And I think everyone is aware of streaming platform nowadays because everyone is like running after OTT, OTT, OTT. So, okay, data is being generated. We are generating this data since past few minutes. Okay, so what is API? Let's say you are doing web scraping. If you are a data analyst, you would know about this. If not, still, let's say if you want to fetch some information which is available on an application or on a website, so you use API. API is nothing but just a connector between the websites. So if you are pulling some information using API, that falls under data generation. If you are doing anything on a website, let me give you an example. If you just open your Amazon website or Amazon application, you place an order. You just, okay, before placing an order, you just clicked on the item. Okay, that is data generation. You just selected the quantity. That is data generation. You just selected the address where you want to ship. That is data generation. And at the end, you paid the amount. That is also data generation. You receive the confirmation message. That is also data generation. You receive the shipper address or shipper details. That is also data generation. Yes. Let's take another example. You are using any OTT platform, let's say Prime. So if you are searching any movie, let's say you search any latest movie. I don't watch movies, so you can just imagine your favorite movie. So that is data generation, that this person, okay, let's draw a person. This person just searched a movie because he wanted to watch a movie. So this person went to Prime and he searched a movie. That is also data generation. Okay, but how we know like what data is being generated and where do we are storing this? So here is the catch. So as we talked about data generation, but obviously if data is being generated, we need to save, we need to store this data somewhere, right? Yes, you are right. So we save all this data to a storage. Let's say there's a data engineer and obviously he's working in any organization. Just imagine he needs to use the data that is being generated. How he can use that data? How? Just tell me. Okay, I know this person. Let's suppose you just searched a movie and you searched your favorite movie, you watched it, you rated it, you did everything. But being a data engineer, you need to use that data. How you will use that data? You will use from this cylinder. This is not cylinder, this is just a database. So you will use that information from this database. Yes, because you as a data engineer do not understand anything like if anyone clicked on something, if anyone searched their favorite movie. No, we just understand data in our data source. If we have data in our data source, yes, we can use that, because being a chef, you just need raw ingredients. You need potatoes, you need carrots, you need spices, everything. You do not need to take care of who brought that carrots, who brought that potatoes. No, it's out of our concern. We do not want to know. We just want to know, are carrots there, are potatoes there, are seasonings there, everything is there. Okay, I can just start cooking. So we will be consuming, we means we as data engineers will be consuming each information from this data storage. Now what are the different types of data storages, like what we can use? So basically data storage can be anything. Anything means, okay, you would be familiar with, let's say, SQL databases. Very popular, man. Just like, come on, man, come on. So SQL databases, you would be familiar with SQL databases. That is relational databases in which we can like store our data in relationships. We will be discussing that as well, don't worry. So SQL is like relational database. And then, so SQL databases means like we have structured data. Yes, we have structured data. What if we have unstructured data? Because right now we are dealing more with unstructured data or semi-structured data because of the big data size. So for that we have something called NoSQL. NoSQL, what is that? So NoSQL doesn't mean no SQL. It means not only SQL. So they are trying to say we have other forms of data which are not just in the SQL format or just in the structured format. So that means not only SQL, right? So this was all about data generation and generated data being stored somewhere in the database, in the, you can say, NoSQL database or anywhere. Right. So okay, we just highlighted databases. So do you know the favorite topic of data engineering domain related to databases? What is that? Let me show you. It's none other than data transformation. Yes, it is the favorite spot for data engineers. Why? Because when I talk about data source, you as a data engineer will not be managing this thing. Yes, no, you do not need to manage this. So who will be managing this? Maybe a DBA. Now what is DBA? So basically database administrator, who basically designs the databases and relational database management system. So you are not much responsible for this thing. You are responsible to use this information and convert it into this cleaned database. Yes. And how you will be doing it? Using data transformations. Because I just mentioned that you can get messy data, you can get data which is not even linked to any other database or any other data source, but you as a data engineer are responsible to create this kind of clean database. Because if they want to, just imagine, if they just want to query or just use this database, why do they require data engineers? Obviously, they do require because they want to query this database. Why? Because it is highly efficient for reporting. It is highly efficient for downstream. What is downstream? We'll be covering. Wait. We'll be covering each and everything. Wait. So this is the area where you are working maybe 70 to 80% of the time, transforming that data and just making some useful data out of that garbage data. That is also called as curated data. So you are basically responsible for making curated data out of raw data. Yes. So you are leading this area. So try to focus more and more in this particular area. How we can just focus on this area. That's why we have this video. So these are really basics of data engineering. Don't worry, because we gonna level up very soon. These are just very basics. So if you already know these things, then it is a good revision for you. If these are new to you, then definitely these are like building blocks for you. So just be confident. And now in the three pillars, we have covered two pillars, that is transformation. Now comes the third pillar, the data modeling part, or maybe data serving. So, oh, I just wrote data transformation. So just ignore this, just write it here, data serving. So just make this correction in your notes. This is data serving. Just cut it. I'm just following my legacy, because in my school days, I used to do lots of cutting in my notebooks. So maybe that came because of that habit. Okay, no worries. So this is your transform data. Okay, so once you transform your data, can you present it? No. Why? Again, just go back to the analogy. You as a chef just prepared the dish, and you have the dish in maybe big utensils. Now you want to serve each and individual customer, right? You cannot just serve the whole dish which is in the big container, and you cannot ask, okay, let's eat. This is your dish, just eat on your own. No. That's very wrong. No, we cannot do it. So we need to just serve that data. And how we can serve? We serve that data into in the form of, you can say, small dishes. So let's say this is your food that you cooked in this big container. Okay, this big container, and these are some of the smoke, and you need to serve this data into small dishes. See, according to the requirements, they have ordered half plate, they have ordered full plate, or maybe they have just ordered something else with their plate. So you need to responsible for different categories of customers. I hope my analogy is making some sense, because I was thinking like how I should just explain these things. Then I just came up with this idea, and I hope now you can relate it, because I have practiced this in my learning days as well. When I related with real time scenarios, you can say real time analogies, you learn better because you can remember those concepts and you can relate it with your real time scenarios or activities that you do. So instead of serving the data in the big utensils, you create data model. You create data model. I hope now all the three pillars of data engineering are clear. These were like basics of basic, like basic of basics or basic of basics of basics that you should aware of. So this was all about data generation, data transformation, data serving, right? Yes. So now it's time to level up, and now it's time to cover some terminologies that are really helpful in the world of data engineering. And yes, they are really important. So I hope you have just made notes of these things, and you can obviously just take notes and you can just use these examples, because the thing is, now I know these things are funny, but remember one thing: whenever you try to relate these critical concepts with the things that you do normally, you can learn really faster. Trust me, this is something that I have tested. So whenever you create, like make your notes, you can just put these examples. You can just create small drawings. Bro, you should not feel like ashamed by drawing these things. Trust me, because you are the one who will be revising from your notes. If you just look at my notes, you will laugh, but that helped me a lot to grow, to learn critical concepts. So just follow my advice, just draw these things, and you will see that you will be growing exponentially. Because whenever you will just revise these concepts, you just need to look at the diagram and you will feel that analogy and you will just have those concepts in your mind. Trust me, you do not need to read theory. You do not need to just read one like theories again and again. No, just revise like this. So this is a kind of tip that you should follow in your learning journey, and just draw anything, man. It's your notes. You are owning them, and it should be unique. If you want to just follow formal notes, you won't feel related. You will feel bored after some time. Just make creative notes so that you will feel joy whenever you will be revising. You will be revising those notes. So our three pillars are covered. So now it's time to level up a little bit and just have a look at the terminologies that we have in the world of data engineering. Okay, so what is this? First of all, upstream, downstream. So this is a kind of term that is very popular. So what is this upstream, downstream? I also use this term, I remember. So it's time to use, like, demonstrate this term. So the thing is, you are a data engineer. I'm imagining that you have become data engineer because I know you are my data lovers, you are my data community, and I know you are really hardworking. And if you are trying to crack a data engineer role, you have already cracked it. So I am imagining that. So you are a data engineer sitting in a company. Let's say, okay, it's your dream company. Let's type it here. Dream company. Okay, it is your dream company. So you are a data engineer. Who is your upstream and who is your downstream? Now, first of all, please tell us what is upstream and downstream. Okay, bro, let me tell you. So upstream, as the name suggests, that is coming from the level which is up to you, like not by, you can say, power, or position just the level of stream. Like stream flows like this. Let's say this is a stream, right? And this is the water. So this flows like this, right? This flows like this, right? You are sitting in the middle. So this is your upstream, this is your downstream. This is the basic example that I could have used. So now you are a data engineer sitting in the middle. Who is your upstream and who is your downstream? That is the question. So if you just remember, if you just revise the concepts, if you just revise the three pillars, you will get the answer. So as we just talked about that, we get the data in the data sources. Let's say this is my data source, maybe any SQL database, right? Any CSV file, any API, anything. And I just talked about that. All these things are managed by DBAs, okay? DBAs, and sometimes these are also managed by software engineers or software developers or web developers, because when you are working in a small organization, so sometimes like web developer or software engineer or software developer will be just storing the data as well in the databases. So he or she will be managing the data source. So I can just write here, let's say software developer, right? So all these persons, all these professionals are your upstream, because data is flowing like this to you, okay? This is your upstream. Now just comment me, like comment down, what will be your downstream. Okay, you guessed it right. So your downstream will be to whom you are serving the data, whom you are serving the data. Obviously you need to serve data to, let's say, just ignore my drawing, he is a data analyst. He is what? Data analyst. Or he is a data scientist. He can be anything. Data scientist. Or he can be maybe analytics manager. Yes. He can be analytics manager as well. So this will be your downstream. So downstream, upstream, clear. So data is flowing like this from upstream and from downstream. So data is flowing like from upstream to downstream. So here, do not feel like data analysts are like below data engineers. No, it is just the stream how data flows, right? And you need to be very, very, very professional with both, with your upstream, with your downstream. What do I mean like being professional? So the thing is, you need to you need to be having conversations with your upstreams regularly and with your downstream. Why? Because you will get the requirements from your downstream, correct? You will get the data from your upstream, and you as a data engineer need to figure out how to sync both. So first you will get the requirements, then you will talk to your upstream as well if you want to make some changes in the source system. Maybe for any kind of specific project, you need to talk to them and apply those changes in the source. So you need to be responsible for both the ends. So just try to maintain healthy relationships with both, with your upstream, with your downstream. It is really important, because if you will not be having, maybe you can say, good conversations with one of these streams, this is not gonna work. You need to have good understanding of, you can say, how they are working and how they are just doing their work, not much in detail, but you should have some basic understanding like how they will be using the data, right? So this was all about upstream and downstream. Now it's time to discuss another important concept. What's that? It's OLTP and OLAP. Let me tell you my story. When I was learning this, I was like, what the is this? Like, I referred so many resources. I'm not lying. I referred so many resources in my early days because I was not getting this concept. But once I mastered this concept, I was like, bro, just ask me this question. I will just answer you. So when I was just preparing the slide, I was living those moments when I was suffering to just find the resource. So I have decided that I will tell you this concept in the easiest way. And after covering this, you do not need to go anywhere else for this concept. Trust me. Because we call it as OLTP database and OLAP database. We call database to both, like we give name to database to both, and the reality is something different. Let me start. Okay. First of all, first of all, give us the full forms of OLTP and OLAP because we do not know anything. Okay. So for that, I would say OLTP is online transactional processing, correct? And this is online analytical processing. Perfect. Okay. We understood the full form. Now what is this? First of all, just focus on the left part. This part, OLTP. Just forget about the OLAP for now. Just give me a few minutes. I will just explain each and everything. For OLTP, so far we have discussed that our source, let's say this is our source, a SQL database. This is managed by whom? Managed by DBAs or maybe software engineers in some companies. But for now, let's say DBAs. Okay, this is managed by DBAs. Yes. So what they do, they let me just draw it again. What they do. So I hope you have just noted down the full forms. So now it's time to just give you a demonstration. That's why I removed everything. So what they do, let's say they have these sources here, maybe a website, maybe their blog page, maybe their OTT platform, everything. So they just use this whole data and they just write it somewhere. Where? In the database. Okay. In this database? Yes, in this database. When they write this data to this database, this one, this is called OLTP database. Understood? This is called OLTP database. So why do we use word transaction? So the thing is, we write data which is in the transactional format, which means like we need to store. Let's suppose you are just using any banking information or like banking application. We need to write all those transactions one by one, right? So that's why we call it as transactional database because we are storing transactional information. So whenever we design OLTP database, we say that we need a database which is very much efficient for writes, which is very much efficient for writes and updates. Okay, why? Because we will be storing data in chunks, in smaller quantity. Yes, let's say 10 users just clicked right now. So that 10 users will be added into this database. This is called OLTP database, and that's why we say we need high write performance, high update performance. Oops. So this was all about OLTP. OLTP. This was all about OLTP. Let me give you a brief summary that we discussed. So this is your data source. 1, 2, 3, anything. This will be stored in this database, OLTP. And one more thing that we just discussed, it is efficient for writes and updates. Simple. Now it's time to discuss some popular OLTP databases that we are using. So in most of the scenarios, we use relational databases, and the ones that are popular are PostgreSQL, MySQL, or you can say MS SQL Server, Oracle databases. So all these are efficient for transactional databases where we need to store transactional data for writes, updates. Yes. So this was all about OLTP database. So now one question I want to ask, and that will test your knowledge as well. Tell me one thing, who will be managing OLTP databases then? Yes, you are right. DBAs. You will not be managing OLTP databases. You will treat OLTP database as your source, because this is a source for you. OLTP database is just a source for you. So if DBA manages it, how he manages it? So he uses a concept called modeling. He uses a concept called modeling. Okay. Now the modeling that we use in OLTP is called is also known as relational database modeling, and very popular term, like which technique we do use while modeling our data in OLTP. It's called normalization. Yes, I know. Now you are relating your things with, yeah, like your data things with data engineering. So this is normalization. Here we have first normal form, let's say 1NF. We have second normal form, right? We have third normal form. Actually, we have 6 to 7, but till 3 we follow, but after that we do not follow. Why? It is very critical, or you can say it becomes very difficult to manage those 4 or 5th or 6th normal forms. It is easy and it is recommended to follow normal forms till third level, like third normal forms. Perfect. So this was all about OLTP databases. I think now you understood the concept. But being a data engineer, we do not need to know much about OLTP databases. This knowledge is enough, because you will not be responsible to create one normal form, second normal form, third normal form. No, DBAs will be doing it. So what we will be doing then? Okay, you have something else. You have OLAP databases. Now, what's the full form? I just mentioned this. Online analytical processing. First of all, that I was so confused after hearing this. OLAP databases is also known as, if you know, just comment down, is also known as data warehouse. Yes, this is data warehouse. When we talk about OLAP database, we are referring warehouses, data warehouse. Now, what is a data warehouse? Basically, it is a kind of database, obviously, but we we as a data engineer try to make it efficient enough for, yes, for reads. Why? But why? Because in OLTP we discussed that it is for writes and updates. But in OLAP you are saying, bro, it is for reads. Why? Bro, okay, first of all, bro means both boys and girls. So do not, like, I'm not just teaching my boys, it's like I'm also teaching girls. So bro is like just combination of both. Like combination means like different entities. So Bro, why do we need faster reads? Okay, let me tell you. Let me tell you. Should I just clean it first? You have just taken the notes, I guess. Okay. Okay. Let me tell you everything. Okay, this is your OLTP database. DBA will be taking care of it. Okay. Hey DBA, just take care of it and just maintain it nicely. I'm just kidding. Don't use these words, bro. I told you that you need to build strong relationships with both the streams, upstream and downstream. So this is your OLTP database. Now, I mentioned this. I mentioned this. We have so much of data coming. We have data coming from website. We have data coming from OTTs. We have data coming from some other entity. So all this data is being stored. Okay. And yes, these are being stored individually. But imagine the size of the data it is carrying now. It's huge. It's huge because it is being stored every second, every millisecond. Now, now you need to query this. Can you query this heavy data set? No. It's so difficult to pull this data to your reports. You cannot pull this heavy data set. No, you cannot. Your reports will be like dying to read this much of data. So how do we do that? We create something called OLAP database. We create data warehouse which is efficient for reads because our reports means our organization's reports will be referring our data warehouse instead of theirs. Don't mind my drawing, bro. So so this is my report. Let's say this is my report. So instead of querying this database, which is so heavy, it will query this one. So we have to make our data warehouse in such a way that it can handle high query reads, like which are querying large amount of data. That's why we have created data warehouse, which will handle high reads. Yes, which will be handling high reads. So we need to model our data in a different way. We cannot use normalization, or you can say first normal form, second normal form, third normal form. No, we use a new, or not new, like just a different modeling, but yeah, new. If you will compare the dates, I think normalization came before than the modeling technique. So we will be covering that modeling technique as well. So just for now, do not feel overwhelmed by just having this word in your mind right now. I'm just writing it for now. It will be explained later on. So the name of the modeling is dimensional modeling. Dimensional modeling. Do not feel overwhelmed right now because I will explain this. So we use dimensional modeling for OLAP databases so that our reports can easily query this without any hassle. Yep. So we as a data engineer, we are responsible for this because if anything happens in this area, we are responsible for that. So you need to make sure that you are building this OLAP database slash data warehouse nicely because you are the owner of this platform, not this one. That doesn't mean that you should not know anything. You should know like some of the basic concepts like normalization and how you should apply joins and all. That's it. You should know just little bit about your data source. Then you need to focus more on OLAP side. I'm just talking from the practical perspective, not from the business perspective. Obviously you should know a lot about your data source if you will just see it from the business perspective, but I'm just talking about the technical side. So you should focus more on OLAP database. Okay, and what are some popular data warehouses we have? One is Warescape. This is a kind of on-prem data warehouse tool, and I have personally worked on it. It's a great tool. Then we have Snowflake, that is a cloud data warehouse tool. We have Synapse Analytics, we have Redshift, we have so many data warehouse tools. Don't worry, we will cover it in just few minutes. So this was all about OLTP and OLAP, and I hope now you have understood each and everything regarding this topic, because I was like I referred so many videos, so many books, so many like different articles, blogs, and I think this was all about OLTP, OLAP. If you didn't understand completely now, just rewatch this part, because it is fine if you just rewatch the part. Because the thing is, do not feel that you are foolish or you are not smart enough to understand the concept in one go. No, bro. Just try to say to yourself that you are deeply understanding the concept. No one is perfect to just grab everything in one go. No. You need to rewatch. You need to rewatch to deeply grab those concepts. And yes, if you have just rewatched this part, now it's time to just level up and go to OLTP to OLAP. Now, you would be asking, bro, you have talked about that we use it as our source and we create OLAP, but how we do that? How we do that? Is it a magic, or do we just need to press a button so that it will just create a OLAP database? No. We follow a process, or you can say a technique, or a kind of activity. It's called ETL. It's called ETL. And I know this is a very popular term in the world of data engineering. You must have seen so many job postings that ETL developer, this developer, that developer that needs to do ETL. So ETL is nothing but extract, transform, load. Okay, that is the full form, but explain us in detail. Bro, that's why I'm here, and I will explain you each and everything. Extract, transform, load. What does that mean? And like we need to know each and everything in ETL. Okay, let me tell you. So basically, this, again I'm explaining this concept. This is your source. Okay, you need to transform this data. Okay, I have transformed this data. Okay, okay, and you have created your OLAP database, which is also known as data warehouse, right? So whenever you hear the word data warehouse, that means OLAP database. You have created it. Let's say you extracted your data from the source, you transformed that data, and you created the data warehouse. Done. What about next day? What about the third day, fourth day, fifth day? Will you be doing each and everything again and again? No. For that purpose, we create ETL pipelines. ETL pipelines. That's why we have here persons who are designing the pipeline. Why do we need the pipeline? So, bro, the thing is, let's say you have the source, right? It will be updating, let's say, every hour, right? You need to pull that data automatically and push that data to your data warehouse that you have constructed. For that purpose, you need to create pipelines. What? Pipelines. It's not like water pipeline, but it's similar to that. Because in water pipeline as well, we have a big dam or maybe a big tank of the area. Then that water travels through the pipelines, and whenever you open the tap, you get the water automatically. You do not need to go to the tank and just carry the buckets and fill the water and come back home. No, you just need to open the tap. That's why we call it as pipelines. And obviously we call it as data pipelines or ETL pipelines. So our pipelines will extract the data, will transform the data as well. Obviously you have built the logic. Then you will automatically load the data in your data warehouse. It's exactly similar to the water pipelines. Exactly similar. So I think this critical concept is like just a cup of tea for you now, because you know what is ETL. Just revise this thing that we have just talked about. Extract the data, transform the data, and load the data through pipelines, through pipelines, because we do not want to do manual work again and again. We need to do each and everything automatically. That's why we have pipelines. It was all about ETL, and I hope now you have a strong understanding of ETL. Then, my favorite topic. Really, my favorite topic. Reason? Because this is a topic that not everyone is like focusing on right now. I don't know why, but this is really important. And you would be asking like, from where you are covering these topics? So, bro, the thing is, I have read some books, like 2 to 3 books, and those are referred to as father of data warehousing. And these are the topics that are not available everywhere, but once you know these concepts, you can become an efficient data engineer, because these are the terminologies, or you can say these are the concepts that we are currently using in the cloud era as well. Hey, what is cloud? Just forget. Sorry. Not, like, I didn't use any word related to cloud. No, because that word will be discussed in detail in just few minutes. So just forget about that word. No cloud, nothing. So I was just kidding. It's time to just focus on data warehouse in detail, because obviously you are the owner, so you should know each and everything of it. Data warehouse, we know that we have dimensional modeling in data warehouse, and I have promised that I will just explain you each and everything about dimensional data modeling. Okay, so now what are these layers? What are these layers? What are these layers? Why do we have layers? So when we just pull the data from the source, right? Let's say this is our source. This is our source. When we just pull the data, what do you think? It directly goes to create the data warehouse? No, no. We have layers. We travel our data. Yes. So the thing is, let me show you the complete, like, the how things go between these layers. It is really important. Let me explain this. So let's say this is your source. This is your source, right? Source means maybe SQL database, anything. OLTP database. Now you are aware of OLTP database, so now I'm fine to use that word, OLTP database, right? Maybe this is a PostgreSQL or MS SQL server. This is your source, and you need to create this data warehouse. For that, we have two layers. What are those layers? Those are known as staging layer and core layer. So what is the staging layer? What is the staging layer? I know this term is like quite faded now, but this is being used in cloud, but people do not even know the name of this layer. This is called staging layer. So what happens? We pull our data, basically extract our data to this staging layer, to this layer, right? Layer, you can say a kind of maybe folder. For now, you can just imagine it as a folder. We have two folders, staging and core. So we first extract our data to staging layer. Yes. And then from that staging layer, we transform our data, and then we push it to core layer. And here we have fact and dimensions. What did I say? Fact and dimension. So this was just a hint for you, because next topic will be related to this one. So dimensional modeling is all about facts and dimensions. We do not know anything. So what? You will be knowing it very soon. Just have this knowledge for now. Here in this core layer, you have facts and dimension, or let's say for now I can say dimensional data model. So before actually creating this, you create a staging layer where you dump that data, and then you take that data from there. Why? Just give me a reason, because this is the interview question that you can be asked. Why? Because the thing is, you should not query the data directly from here, because it can slow down its performance, and we do not want to do that. That's why we create a staging layer, and we use this data. We use this data for our core layer. And let me just clean this stuff. you should draw this like this, because you will be having a flow, like how things are going. And after that, we have something called a breakdown of staging layer. So we have two types of staging layer. One is called transient, and second one we have persistent. So this is called as persistent. What's the difference between two? So basically, transient layer is temporary layer. What's that? It's temporary layer. So what we will doing, let's say today we just push the data in this layer. Okay, we then use this data to create the core layer. Okay, next day this data will be truncated. Truncated means deleted. Then we will just feed the new data. Why do we do that? Because we do not want to use that data that we have already used. That's why in that particular scenario we use transient layer. And let me tell you, in the industry we use transient layer 99% of the time. Then why do we have this persistent layer, and what's the meaning of that? If you want to preserve this, if you want to preserve this, if you want to preserve the history of this, then you create a persistent layer where you store the data and you just keep updating the history. That's a very rare case, and that totally depends upon the project you are working on. But trust me, 99% of the time you will be working with transient staging layer. So this was all about data warehouse layers. And I know now you have some extra knowledge that will give you an extra edge over other candidates or other data enthusiasts, because now you have landed on this video and have learned some amazing knowledge. So this was all about data warehouse layers. Let's jump on to the favorite concept, incremental loading. And this is the concept that people call it as complex or advanced concept. What if I tell you that I will just explain this concept in just few minutes, and you will know this critical complex concept in just few minutes? So basically it is related to staging and core layer. So the thing is, we just discussed this. What is, first of all, incremental loading? Just tell me, what is incremental loading? So incremental loading is a part of, you can say, kind of data fetching strategy. So let's say this is our data source. Okay, and we have this data till today. Like, let me just type it. Let's say we have data for like maybe Jan 2024. Let's say Jan 2024 from let's say Jan 2023. Okay, so this has the data from Jan 2023 to Jan 2024. Perfect. Then we just pushed the whole data to staging. Okay, then we push this data to core. Okay, and we created the dimensional data model. Okay, this is my dimensional data model. Okay, this is absolutely fine. But after loading this data, I have the data. Let me just remove it. I have the data for, let's say, Jan 02 2024. Then in that scenario, I will not be pulling all the data, because in this particular source it has all the data, right? Like January 2023 to 2024, and then on the second day of Jan we have the 1 day of data more added to this particular source. Do you think we should just pull all the data again? Because we have data here, like till, let's say, from Jan 2023 to Jan 01 2024. We have this data here. We have this data here. Why I should pull all this data again, and why I should use so much of computation to pull all the data? Here comes the concept of incremental loading, where I will just load this data, only this day of data, only this one. I will just ignore this data, uh, this data, which was Jan 2023 to Jan 2024. Jan 2024 means Jan 01 2024, right? I will not take this data again because I already have this data. So I will neglect it and I will only take this data and I will incrementally load only this data into my staging layer, and I will incrementally load this data to core. Then my core will have this new data, this Jan 02 2024, and this cycle keeps on running. This is the concept of incremental loading. Was it critical? Was it complex? No, it was easy. It's just the matter of once you are introduced to the concept in the right way. So that was all about incremental loading. And let me tell you one thing. This is the practice, or this is the process that we always follow in the world of data engineering. We do not pull all the data again and again. We incrementally load this data. And that's why this is the favorite question of the interviewers, that what is incremental loading and how we should apply incremental loading. This is the favorite question. And now you are all set to answer. It's not just about answering to the interviewers, it's also about your knowledge as well, because you as a data engineer will be working on these concepts. You should be aware of it. So this was all about incremental loading. Now let's jump on to our next topic, our favorite topic, because this was on hold since very long, which is dimensional modeling. Okay, what is that? Please explain us, because we have heard enough of it. So bro, hold your breath. I'm just kidding. So dimensional modeling is really simple. It is basically a modeling technique. It is basically a modeling technique in which we store our data in the form of facts and dimensions. What did I say? Let me repeat. Okay. So in case of OLTP database, we store our data in first normal form, second normal form, third normal form. We create the relationships, correct? We use SQL to build relationships and all. In case of dimensional modeling, we create table model or data model in which we have one fact table, then we have dimensions which are linked to this fact table. Yes, which are linked to this fact table. Okay, okay, okay. Now just tell us how to decide, or how these tables are different from each other. Like how we can pick fact, how we can pick dimensions. Because in normalization, we pick on the basis of normalization rules. Do we have rules here? Yes, we have rules here. What are those rules? Okay, so first of all, the rule is for fact table. Just focus on this one because this is in the spotlight. Just focus on this one. In this fact table, we will only store the numeric values. Only numeric values, nothing else. Only numeric values. Let's say we have a table and we have columns like product ID, customer ID, this ID, that ID, and their information. Then we have something called such as price, or we have bill, or we have MRP, or we have quantity, or we have, let's say, weight, or like how heavy it is. All that information in which numbers are there, we use that information to create fact table. All that information, and rest of the things will go to our dimensions. Now how to create this dimension, because fact table will be one, correct? How to create multiple dimensions? For that, let's say in your table you have customers data, customer's name, and you have, let's say, customer address, customer personal information such as card information and all that information will create one dimension. That's called as customer dimension. Let's call it as customer dimension. Let me write it for you, bro. Customer dim means dimension. This is your customer dimension. Then in the table you have product information. Let's say you have, let me say, product information such as product name, right? You have product category, something like it, right? All that information can create a different table, and that can be called as product dim. That can be called as product dim. Similarly, if you have more clusters of data which can create a different table, you can create dimension for that. That's why we call it as denormalized data, where data is not normalized. It is semi-normalized or very much less normalized. It is clustered based on the business use case. Because we know all the information related to customers should be in the customers table. Perfect. All the product information should be there in product table. Simple. If data is redundant, still we will just keep one dimension for that. That is all about facts and dimensions. Everything is sorted. Just one question. I know you are going to say this. I just read your mind. What is a star? What is this star? What why have you written this star? So the thing is, we have basically two types of dimensional data models. One is star schema, one is Snowflake schema. Just clean everything and just write it here because we need to see. Okay. We have two types of dimensional data models. One is star schema, another one is Snowflake schema. Snowflake schema. So this is star schema. This one is star schema. Why we call it as star schema? If you observe it closely, you will see one center is surrounded by different dimensions that creates a shape of star. That's why we call it as star schema, or you can say star dimensional data model, but common name is star schema. So this was all about dimensional data model and its first type, star schema. Okay, now what is Snowflake schema, or is it really complicated? No, there is just one minor difference. And in the real world, in the industry, we 99% of the time we use star schema. Why? Because it is very performant, it is really faster in terms of querying data, and it is really easy to manage. So in the real world, you will be using star schema, don't worry. And still, I will just show you what is a Snowflake schema. It is very easy. Let me show you the other one, that is Snowflake schema. Just observe this for like just 1 to 2 seconds and just tell me the difference. So you have spotted the difference. You have spotted that, bro, we have two dimensions which are attached to one another, and then they are attaching to this fact table. Yes, this is the only difference. When you have hierarchy of dimensions, let me repeat, when you have hierarchy of dimensions, that means one dimension is referring to this dimension, and the whole set of dimension or whole hierarchy of dimension is referring to this fact table. In this scenario, we call it as Snowflake because it refers to the shape of snowflake where they have small branches. So that's why we call it as Snowflake. It is really hard to manage, so that's why we do not deal with this in most of the scenarios, but you should be aware of it. Again, these are all about fundamentals. Yes, so you should be aware, your fundamentals should be really crystal clear. If you are using that thing in future, you should be aware what is that. So this was all about dimensional data modeling. So see, now you know like what is the difference between OLTP and OLAP, and how do you actually model both the things. Normalization, obviously we do not worry about normalization, but dimensional data modeling is really important. This was all about star schema, Snowflake schema, and it's time to jump on to our really important. This is the like most important. If you will ask me like what is the most important topic, like what are the top 3 most important topics, I will place this in top 3. Why? Because it is something that you practice most of the times. It is something that you will be doing, I think, in 99.999999% projects. Yes, like what is this slowly changing dimensions? Obviously, it is little bit understood by reading the name, like it is changing, like dimensions are changing. But what's that? And what are these types? What are these types? What are these types? Type 0, type 1, type 2, type 3. Everything will be explained really quick. Let me go and drink some water because I need water. So let me just go and drink some water and it will be discussed the next as our next topic. So now, yeah, I drank water. So now it's time to discuss slowly changing dimensions. What are these? So basically the thing is, let's say this is your dimension. Let's say this is your dimension table. Let's say products dimension table. This is your one of the dimensions, and product was like easy to pick. To explain you some concepts, I was thinking to just pick some screenshots from the book, but I thought like I should just create one simple example so that you can easily digest this concept. So the thing is slowly changing dimensions. So as we know that our dimensions hold all the contextual data, non-numbers data. So, or you can say categorized data. So if that data changes, that should be changed in the dimension as well. That's like pretty much simple, right? But it's very difficult to deal with those changes, and that's why we have created type 0, type 1, type 2, type 3 slowly changing dimensions. There are like I think two more, but we do not deal with that. So we just use type 0, 1, 2, 3. That's it. What is that? What is that? Okay. So my favorite is type 0, not my favorite, just kidding. So my favorite is type 0. The thing is, in type 0, we assume that our dimension table will not be changing. It will not be changing. No. So type 0 is the one that you can say not a type. That's why we have numbered it as 0. So when we know that our dimension table will be fixed, right? That's sorted because we do not need to keep the values updated in the table. Okay, so type 0 is done. It is very simple. Now comes the type 1. And before jumping on to the type 1, I will give you one scenario. Okay, let's say this is my dimension table, and let's explore this. Product ID 123, name honey, shirt, and comb. These are like product names, right? These are product categories: food, clothing. Now this dimension was being fed in our dimensional data model. Now there's a change in the source. You remember we fetch the data from the data source. Let's say in our OLTP database they have made this change that comps product category is not clothing anymore. It's hair. Maybe hair accessories, or let's say product category is hair. How we will tackle this change in our dimension table? To tackle this change, we have three concepts, or you can say we have three options. Option number 1, type 1. Option number 2, type 2. Option number 3, type 3. We will be discussing all these three types in detail because this is really important. So just put your highlighters on your notebooks because you need to be just creating lots of examples and lots of scenarios, and you can definitely create this table as well in your notebook so that you can just draw it and you can just learn it because it is really important. I have manually created this table in Excel to just explain you because the examples that are in book is like little bit hard to understand because of so many columns, but I just wanted to explain you from the scratch. So I have created this one, so you can just create it in your notebook. That's all. So let's get started. How we can just deal with this change. You know the scenario, right? The scenario is the name, product name is com, and that product category will be hair instead of clothing, right? This is the scenario. Let's discuss how we will handle this in type 1. In type 1, We call it as upsert. Yes, we have heard this word for the first time. What is this upsert? We have heard update, we have heard insert. What is upsert? So it is the combination of update plus insert. Why I have mentioned this word? Because this word will be used in the interviews. They will not tell you that we need to apply type 1. They will just say we need to apply upsert, which SCD, slowly changing dimensions, is also referred as SCD. Which SCD should we use? It should click in your mind. Okay, upsert means type 1. Now let's understand this. Let's say this is our before scenario, that this was our category and we need to create something like this. So we overwrite it. Type 1 means overwrite. Type 1 means overwrite. Overwrite the value. So as you can see in this example, we have just overwrite this thing. Earlier it was clothing, now we have hair. Simple. Now whenever this dimension will be linked to our fact table, we will be seeing com, or you can say product ID 3 as our hair product category. So it can just fetch the information according to that. Clothing category is gone, for com is gone. So this is the most used SCD. This is the SCD that you will be using, I think, at least 70 to 80% of the time, because it is easy to manage. It is very easy to manage, and again it is performant enough because we do not need to keep up the history. Wait. First understand this completely. So just to summarize again, in this we just apply update or insert, and we just use override statement. Simple. So let's say we have a new value here. Let's say we have a new value here. Let's say 4, and we have here, let's say, shoes, and then we have here category as footwear, right? So why it is called as upsert? So what it does, it will see, hey bro, do we have any product with this ID? It will say, let me search. It will say no. So it will insert this record into my dimension table. That is the one part of it, insert. Then wait, hold on. Then it will say, hey, do you have any record with 3 product ID? It will say, hey, wait, let me check. It will say, yes, I do have. Okay, just update it. Simple, update it. I do not want to ask anything else, just update it. So what it does, it just updated my product category to here. Update plus insert. If there is any new record, it will insert. If there is an existing record, it will update. So behind the scenes, what people do not explain, behind the scenes, it has actually updated these 2 records as well, but we didn't see any update. Yes, that is the catch. It has updated all the information, but the thing was, updated information was exactly matching with the existing information. So we didn't see any update, but behind the scene, it has applied the concept update plus insert. If any new record is there, insert it. If any old records are there like 1, 2, 3, just update everything. I do not want to ask. Sorted? So I tried my best to explain this concept in the easiest way, because slowly changing dimensions are really important and people do find it difficult. So if you have understood this, then congratulations. Now it's time to discuss type 2. Type 2, why do we need it? Because our work is getting done. No. what if I want to keep the history, like in what way? So the thing is, what if I want to keep the record that com's previous history from this date to this date was clothing, but after some date it got changed. I want to preserve this history. It is very rare case, like not every time we will be using type 2, but we do use. So it's time to discuss the type 2, that is keeping the history. So we design our dimension in a specialized way. Specialized way. Wow. What's that? It's really simple. So you just need to add 3 columns or 3 attributes. What are these 3 attributes? So these 3 attributes are start date, expiry date, and one flag which states is this value in use or not. So for that, if we want to tackle the scenario, the change with type 2, so we will be adding 3 columns. What's that? See, one is start date. Start date is, let's say, 1st of January 2024, 1st of January 2024, 1st of January 2024. And expiry date, we will put some big date which is so far from now, like 3000. Okay, so 3000. That means these are not expired yet. We are using these values. And one more flag, is this in use? Yes, yes, yes. After we have change, after we have a change, what we have done? We have inserted a row. We have inserted that change as our new row, and within that we have mentioned that our previous record was effective from 1st of January to 2nd of January, because we assumed that it was changed on 2nd of January. And in use flag, is it in use right now? No, it is not in use, because we are using this value com here, and is its effective start date is 2nd of January and expiry obviously a long time from now. Understood? Understood? Just rewatch this part. Just rewatch. It's really important. If you understood, please rewatch this part, because I am saying, because you will revise this, and once you revise this you will just absorb it. This was all about type 2. It is, I know, a little bit tricky. We will be using type 1 most of the times, but you should be aware of type 2 as well, because interview can ask you, hey, you are a data engineer and you want to design a dimension for us and you want to keep the history as well. Then you will answer, okay, then we can go with type 2. And once you say this, interviewer will know that you are aware of type 1, type 2, type 3. Now, you are not aware of type 3 now. For now, let me make you aware. So here is the type 3 value. What we do special in this, because now our all the tasks were done, like why do we have type 3? So this is type 3 is like really performant, plus it does not preserve the history, but it preserves your previous values. Like it does not preserve your timings, dates and all. So what it will be doing, I think it is evident enough to just look at the screen. So it will just put your previous value. So let's say this is our before, in which our previous value is same as current value, but after the change you can see our product category current value is here, but previous value was clothing. Yes. So it is a good way to preserve the history without just managing the date columns. And for other 2 records, we have the same previous categories, because these values are not changed. Understood? 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 This was all about type 0, no change, type 1, absurd, type 2, preserving history, type 3, preserving the previous value. Sorted? Because I am saying, just rewatch all the parts again and just make some good notes and just put all the detail, just put all the drawings that we used right now, and then see how you preserve this information in your head. Just do that. Just do that, because I'm saying. So after covering this, Now it's time to discuss a new concept, a new concept, a new concept. What is data lake? Data lake, data lake. Everyone is talking about data lake. Every second person is talking about data lake. Bro, we just got to know how to make data warehouse. Why do we need data lake? Wait, are we replacing data warehouse with data lake? Answer is yes. Yeah. So all the information that we gained is useless? No, because we will be applying that knowledge. How we can apply that knowledge in data lake? All your questions will be answered very soon. I told you, this domain is like full of curiosity. So you should be curious enough to know all these concepts. So first of all, what is a data lake? First of all, let's cover this. So data warehouse was only familiar with covering structured data that was coming in the form of tables, columns, rows, that's it. But but with the growing generation of data, data was being generated rapidly. I would say exponentially. It was very difficult to store all the data in the structured format. So we got data lake. We got data lake. Does that mean that we can store unstructured, semi-structured data in data lake? Yes. Yes. What are semi-structured data? If you have worked with CSV, that is a semi-structured data. If you have worked with JSON, that is a semi-structured data. If you have worked with I don't know. I cannot name like more for now. So if you have worked with CSV or JSON, those are semi-structured data formats. So you can efficiently store the data in data lake. Okay, now we are getting some of the insight or why we are using data lake, because we can deal with, let's say, different file formats. Is that the only reason? No, no. So what are the other reasons? You will get to know. First of all, just have a look at this picture that I got from the Microsoft Learning page. So I have put the reference here as well, because Microsoft Learning page is a good source to learn. There are like so many different documentations. So here, as you can see, it is efficient enough to work with cloud and IoT data movement, big data processing, analytics, reporting, on-premise data movement. So before jumping on to the comparison, let me tell you, this architecture was so good that we were building reports on top of this data lake. Yes, we were using data lake to provide data to data scientists. Like, we were serving all the downstreams so efficiently. And now it's time to just show you the comparison. So this screenshot is also taken from the Microsoft Learning page. Like, I have just did some joins and all to just show you the main difference. So now let's discuss what is the core reason. We just want to know the core reason why we are using data lake. Everything was working fine with data warehouse. First reason is format. We can retain unstructured data, semi-structured data, and structured data. But in case of data warehouse, we were only working with structured data. Oops, no bro, you are not relevant now because we have big data. So what do you mean? Should we just destroy our notes? Wait, no. Just hold your breath for a few more minutes. You will see all your notes are precious because we are using all of them. Just hold on. Second thing is schema definition. So the thing is, when we use data lake, we use schema definition after the data is stored. What does that mean? So basically, when we just store the data in raw format, after storing the data, we define schema on top of it. But in terms of data warehouse, schema is defined prior when data is stored. You can relate it with the data definition language that we use in SQL. We just define the schema before inserting the data. This is different. Major difference. Let me come to the point, bro. Let me come to the point. Why we are using data lake? Because of price. Yes. At the end, business will focus only on the money. They will prioritize money over everything. Data lake is so cheap, it's so affordable, it's so inexpensive that you can store 10 times or I think 100 times of data if you compare like it with normal data warehouse. It's so cheap. Storage cost. Storage cost is relatively low compared to data warehouse and querying result is better. Cost plus performance, both are performant, both are better than data warehouse. Obviously, why would be using the data warehouse? Bro, we are just about to tear out all the knots. Just tell us, is this relevant or not? Answer is, it is very much relevant. Your data warehouse is very much relevant. How? Because now we are in the era of Lakehouse. Why this word is so familiar? Because this word is made up of two things. Warehouse, so we have taken house from warehouse and lake from data lake. So you are trying to say that it is the fusion of both? Yes. Lakehouse means data warehouse plus data lake. Data warehouse plus data lake equals to data lakehouse. Wow. Like, how did we combine both the things? So the thing is, okay, let's discuss it. It is really, really exciting because Lakehouse is like one of the future technology and present technology. Now, what we are doing, we know that data storage cost is really cheap in this one. Okay, data storage cost is really cheap in data lake. Okay, so we need data lake for our storage. Plus, we know that data warehouse is best for reporting because it creates dimensional data model on top of our data, so it is very performant. So we wanted to take the best of both the worlds. We wanted to create data warehouse, that is dimensional data model, on top of the data stored in the data lake. So how did we do it? We just combined both the worlds and we created a world called Lakehouse. We created a world called Lakehouse. What do we do in this? So our data is residing in data lake because it is very cheap. Then we created something called as metadata layer. It's called metadata layer. It is also known as abstraction layer. It is also known as logical layer. It is also known as metadata layer. So what we do, we store our data in data lake. We create the logical layer which holds the schema of the data. Let me show you. So let's suppose this is our data. This is our data residing in data lake. We will be applying a metadata layer, let's say a tabular format layer. Yes, this is the tabular format metadata layer that we have applied on top of this data. Wow. And what does it mean? We are building dimensional data models on top of data residing in data lake. Boom. That is called data lakehouse. That is called data lakehouse, where we have combined both the worlds. So we are using all the terms, terminologies, techniques, procedures, process, ETL, everything on top of data stored in data lake. The difference is earlier the data was stored in the traditional databases in the structured format. Now data is being stored in the data lake, but all the techniques are same. Dimensional data modeling, facts, dimension, SCD type 1, type 2, everything, ETL, incremental loading, everything is same. But just data is not being stored in the traditional databases in the form of tables. It is now being stored in the form of semi-structured data, in the form of JSON files, CSV files, Parquet files. What are these file formats? Don't worry, I have created a dedicated slide for that as well, for file formats. Don't worry about that, but just understand this concept, the power of Lakehouse, the power of future data engineering. And I think now you have everything clear in your head about Lakehouse, about data lake, about data warehouse. Got it? This was the concept of Lakehouse. This is the architecture, Lakehouse architecture. What is Lakehouse? This is the Lakehouse, bro. This is the Lakehouse. Now you are aware of data Lakehouse. Now you are aware of data Lakehouse. And then once we build our data warehouse, or you can say Lakehouse on top of data lake, we create reports, we send the data to data scientists, we send this data to data managers, anyone. Yes, they can query this data using normal SQL, despite knowing that this data is not residing on the traditional in the table formats. This is all being done with the help of this metadata layer, this layer, this layer, this layer. Got it? This is all about Lakehouse architecture. I know this is crazy, like this is so powerful, bro. So powerful. Lakehouse is really powerful. And by the way, this image I have taken from Databricks learning page, because this is the best example that I could have explained instead of just using some images. So this was the best thing. And I think now you are pretty much aware of data warehouse, data lake house. And yes, it's time to discuss the file formats, because that is really important. Now we have something called file formats. Okay, what is this row based, what is this column based? So let me explain you. Let's say this is the data, right? And if we want to store this data, we have different file formats. One file format is row based file format, another one is column based, but forget about that for now. Let's discuss row based first. So what are the examples of row based? So row based file format is like very good example, a very common example of row based file format is CSV. Yes, CSV file format. Or second example is Avro. Avro is like a new one, so just don't put much effort on it. Just focus on CSV, because CSV is very common and very popular row based file format. And when we store this data in row based file format, so basically the difference between row based and column based is how that data is being stored in the disk. Yes, hard disk. Obviously that data is being stored somewhere, maybe on your hard disk, maybe on any server. So the difference is how data is being stored in the disk. Okay, but we didn't understand it completely, because I didn't mention all my points now. Just wait for a few more seconds. Let me explain you. Let's say this is my disk. Okay, this is my disk. This is my disk. Okay, so if I have data in CSV format, okay, so how this data will being stored in that disk? Do you want to know? Let me show you. So let's say this is my data. So first, this record will be stored, then this record will be stored, then this record will be stored one by one. That's why we use row based file formats when we want to write our data efficiently. It is being used for writing the data efficiently, updating the data efficiently. That's why this data format is being used, or this data file format is being used in the OLTP side more, because they want to store transactional data. So let me just show you how this data will get written here in the disk. So first of all, it will just write one, honey, and then food. Then it will write 2, shirt, and then clothing. Then it will write, oops, then it will write 3, clothing. See how data is being written? First, this information, then this one, then this one. So this file format is really good if you want to write your data and update your data. Write and updates. Simple. Because you can easily find one record with any column and you can update rest of the columns, because rest of the columns will be just behind that information. This is all about row based. Okay, now we are really interesting to know column based. Column based is really simple. How data will be written in terms of column based? Let's create the disk again, because disk will remain the same. So let's suppose this is my disk. Then if we talk about column based, in column based file format, first this information will get written, whole column, yes. Then this column will get written, then this column will get written. Wow. So this file format is being used in the OLAP side more, because we need faster reads. How we can get faster reads? Let's suppose I just queried this table, select product ID from dim products, dim prod, right? So my data is being stored column by column. So I can get all the values of this column in one go. But in case of row based, it needs to jump from every record, because our data was being stored in the raw format. Like first this row was written, so it would be going to it would be going first to this record, then it needs to scan the other information as well, because it is written in this format. But in case of column based, this information will get written like this: 1 2 3. Okay, then we have honey, shirt, comb. Okay, then we have, oops, then we have food, clothing, and clothing. So now you know how our data is get written. Now if I query this data, I can easily get all the information for the whole column. Wow. So that's why we use column based file formats when we need to work with big data, and in the OLAP databases where we need to apply reads. Simple. And what are the example for column based? Okay, let me give you the example as well. Very popular example is Parquet file format. Yes, Parquet, and I think ORC as well. If I'm not wrong, just check for ORC. Yeah. So these are some popular column based file formats. And these are some popular file formats in big data. And now you know the reason why these are so popular in big data. So this was all about file formats. Now it's time to discuss something special, but that become the need of the hour nowadays, because I will tell you, after covering so many file formats like CSV, JSON, Parquet, ORC, Avro, it's time to discuss the most in demand and the most new file format that we have right now in the market, and data engineers are going crazy after the launch of this file format. I am talking about Delta format. If you are active on any social platform which talk about some, let's say, any data insights, you must be heard this particular name, delta format. So what is this and why it is very much in hype? So basically this is an open table format. Okay, but we didn't understand anything. Okay, just let me try for one more time. So basically the delta format is an open table format which is built on the top of Parquet format, and this acts as a transaction layer as well. No, we didn't understand this time as well. Okay. Let me just show you with an example. So the thing is, let's say you have your Parquet file here, right? And we love Parquet files. We love Parquet files because of its like high query reading performance. So let's say we have data here in Parquet files, right? Okay. So our delta format is built on top of this Parquet file. Let's say here, let me write delta file, and here you have this file format, right? What is the difference? If it is built on top of it, why do we need to create a new delta format or a new file format which is known as delta format? So the thing is, within delta file format, we get something special. What is it? It is called transaction log. What it does? So basically, if you compare the Parquet file, so the metadata of all the file, metadata means all the column definitions, everything, schema related information, everything is stored in the individual file. But in case of delta, every single information is stored in this transaction log. Okay, and what we get when we store these information in transaction log, so we can use versioning. What is this versioning? So let's say this is my table. So let me just tell you from scratch. So let's say this is my table. I have applied update on it. Okay, I have applied update on it. This is my version number 1. Okay, this is v1. Then I apply delete command on this table. Okay, this is my v2. Then I realized that I do not want to apply delete command. I want to go back to version 1. How we can do that? We can do this with the help of transaction log. This is its superpower. We can time travel. We can go from one version to another version like this. Like this. So if you delete some data, maybe by mistake, you can just travel back and just bring the data back to the time. Yes. So this was its superpower. One of the superpowers, it is basically like having lots of superpowers. One of the superpowers is data time travel. You can create versions. Then second thing is, if you want to evolve the schema, you can do that. It allows us to evolve the schema as well. Let's say we were having 1, 2, 3, 4 and 5 columns. Okay, then suddenly there is a 6th column that is in the source, so we can allow to insert 6th column as well. That's called schema evaluation. That's called schema evaluation. Let me write 6 here. That's called schema evaluation. You can apply schema evaluation or evolution, I don't know. So it's called schema evolution or evaluation. I'm just confused because my mind is like right now fully into the world of data engineering. So I'm imagining everything with broader perspective. So it's called schema evolution. So we can apply schema evolution as well on top of our data. Yes, it is really handy in terms of asset transactions as well. That is its third power. If you are a data professional, you must be aware of these terms. So let me just give you a brief. Asset means atomicity, consistency, isolation, and durability. All these, basically, these are like transactional properties that we get in traditional databases like PostgreSQL, MySQL database. But if we want to use data lake or Lakehouse, we want to get the same transactional capabilities here as well, right? So we get asset transactional capabilities using this delta file format. This is really crazy. When you use delta file format, you cannot even tell the difference between traditional database and lakehouse database or lakehouse table because of the query performance, because of how well it manages everything. And obviously you can just do data versioning as well. Everything you can do with traditional databases, and everything for such a low cost, because data is actually being stored in Parquet file format. It is just this thing that is being added, transactional log. And if you open, if you are curious enough to know a little bit more about transaction log, basically in this transaction log, inside this, we have something called JSON files. We have something called JSON files. Just make notes of these things. Just make notes. So we have JSON files within this transaction log, so that it can just have all the information. Like I have just applied version 1, that information will be stored in JSON file. I have applied delete, it will be stored in JSON file. I want to roll back, like I want to just go back to version 1, that information will also get stored in the JSON file format. So everything will be stored in the JSON file format. How was it? How was it? I know it was super, super, super cool. So now, before jumping on to the next topic, which is very popular, I just want to make a small request which is really beneficial for you. So you are learning really an in-demand technology, or you can say domain. So how you can be an outlier, how you can stay ahead of all other learners. One tip that I personally followed as well, and I want you to follow as well. So let's say you are completing this video. Let's say you are just about to complete this video. You need to go on LinkedIn and just share your learnings, that today I completed this video. You can maybe take any screenshot of your progress, or maybe my thumbnail, anything that you want. Just take the screenshot and just put in on, like put as a post on your LinkedIn portal. How it will help you? You are a new data engineer, you want to enter into this domain. You should showcase your talent, you should showcase your knowledge. How you can showcase that? How the other person will know that you are currently as a data analyst, or maybe you are not even a data professional? How the other person will know that you are capable enough, you have the right knowledge? Once you put the screenshot of this video, and you can just share the learnings, just highlight all the keywords that you have learned, people will notice you. People will notice your learnings. People will get to know that you are capable enough, you have the right knowledge. Follow this practice. Follow this practice. You can even tag me as well. I will just try to maybe repost your post, or maybe just reply in the comments. I will try my best to engage with your posts, so that you will be highlighted, you will be noticed as well, and people will get to know that you are learning so much in this domain. And trust me, not every data engineer knows the fundamentals. Fundamentals are really strong. So my suggestion to you would be, first complete this video, or maybe you will be learning through this video in pieces. Just share your learning journey. Maybe you will see 30 to 45 minutes today, 30 to 45 minutes tomorrow, 30 to 45 minutes day after tomorrow. Just take the screenshot of the maybe you can just take the screenshot of this current screen right now. Take the screenshot, post it on LinkedIn, mention the learnings that you got, mention the skills that you got, and share your progress that I have made this much of progress. And if you want to tag me, I can just comment on your post, I can just engage with your post as well. So just do let me know through messages, or do tag me in your post so that I can engage with your post. Follow this practice, it will definitely help you. How? Because I'm not promoting my videos, just listen to me. The thing is, when you put some content on LinkedIn, you will be highlighted, you will be noticed. Second point, when you will be actually looking at what you have learned, what you have actually gained, you will revise all the things. And when you actually write something, you feed your brain. And trust me, when you summarize something, you just go through all the learnings, because you cannot summarize if you haven't learned all the things. Follow this practice, and I am looking towards engaging with your post. Do tag me in your LinkedIn post, because the next topic is very much popular. Because once you cover that, and once you put that content on your LinkedIn profile, it will be noticed. Trust me. So just share your learning journey, share your learnings through LinkedIn post. Do tag me. My LinkedIn handle is Ansh Lamba. You can easily find it, and just do tag me in your on your post, and definitely it will help you a lot. So now it's time to cover the most in-demand topic. Topic, domain, subdomain, anything that you want to say. It's really, really popular nowadays. It's none other than this one. So now it's time to discuss big data. Big data, big data, big data. Obviously, this term is like self-explanatory, but still, like, what is big data? When we work with large amount of data, it is known as big data. Do we have any scale where we can just distinguish normal data and big data? With my experience, actually, we are working with big data nowadays, because data is so huge right now. Big data is not even a term. Why? Because data is itself so big that we do not need to additionally add this word. We do not need to additionally add big data. We used to add this term that is big to our data few years back, but now data is so huge that we do not need to additionally add big data, but still we do add this term that is big, and I don't think so it will be used in the future, because data means big data because of its rapid growth. Okay, so we have big data, and if we want to work with big data, we have big data frameworks. Wow, what are these? So basically, we have different big data frameworks, as you can see on the screen. So first of all, let's see, what is this? Apache Kafka. So basically, if we want to work with streaming data, real-time data, and that data is huge, that means real-time big data, we use this framework, Apache Kafka. Then we have something called Apache Airflow. So this framework is basically used for orchestration. What is orchestration? Yes, it is similar to the music orchestration. So the thing is, when we need to apply different logics, when we need to build so many pipelines, and obviously there is an order in which we should run our pipelines, all that orchestration task will be managed by this framework, which is Apache Airflow. Then we have something called Apache Hive. If you are familiar with SQL, then you can easily work with this one, because it helps us to create external tables and different databases, external databases using big data framework. Then here is our hero, Apache Spark. Apache Spark is very much in demand. Very much in demand. It is the center of big data framework right now because of its massive power. Companies are running after Spark developers, PySpark developers. By the way, if you want to be a be an efficient data engineer, then you have to refer this big data framework. And yes, this is really important. So Apache Spark, what does it actually perform behind the scenes so that it is so much powerful for our big data? I will tell you. Just hold on, because I have created a dedicated slide for this particular one because it is very much in demand. Now, what is this Databricks? So basically, Databricks is the management layer for Apache Spark, which manages its clusters. What is a cluster, man? What terms are you using? Wait. I will tell you each and everything. What are clusters and why do we have Apache Spark very much in demand? Once you know a little bit about of its architecture, you will definitely say yes, it is worth working with Spark when we want to process big data. So now it's time to just have a look with our Apache Spark. So here is the distributed computing with Spark. What is distributed computing? What is a cluster? What is Spark? Oh, so much of knowledge, right? Okay, let me clear all your doubts. First of all, what is distributed computing? When we talk about distributed computing, let me give an example. It will be very clear to you. You must have gone to your computer lab of your school or your college, right? I'm assuming this. Okay. So what if I tell you, just treat all those computers, 10, 20, 50, 100, I don't know about the size of your computer lab. Just imagine for this example, 20 computers. Just combine all those 20 computers together and create one computer. Just imagine its power. Just imagine its power. And if you ask that computer to process the data, just imagine the speed. Just imagine the efficiency of that computer. That's where we have concept called distributed computing. Just forget about Spark. Spark. Just forget about Spark for now. Just focus on distributed computing. So we have distributed computing in big data. We do not ask only one machine to do our work. We ask multiple machines. What did I say? We ask multiple machines to do our work. When multiple machines come together, it forms a cluster. Now you are aware of both the terms. That's why you can see here, one is the brain and these are the machines. Now let's discuss Spark, because it's high time to discuss Spark. So what Spark architecture includes, let's say this is me, and I said, Spark, please process my this data. Okay, and I sent it to Spark. Okay. Now what Spark will be doing, Spark has something called driver node. What it has? Driver node. Okay, let me just write it for you. Driver node. Now what is a node? Node is basically a computer. You can replace node with computer, doesn't matter. Node with machine, doesn't matter. So node means machine. It has one driver node, one driver machine, which is the brain of the whole cluster, which doesn't do anything. It just orchestrates the work. It just tells the machines that what you need to do. That machine number one, which is yellow in color, you need to do this thing. Machine blue, you need to do this thing. Machine red, you need to do this thing. This will be given by, these instructions will be given by driver node. Rest of the machines will be carrying out the actual work, will be executing the transformations, will be executing the codes. So these are known as worker nodes. Worker nodes. This is our driver node. This is our worker nodes, worker machines. So in every cluster, let me create cluster as well. So this is our cluster. This whole bunch of machine is our cluster. Now within this cluster, we have driver node, which will be only one. Rest of the machines are worker nodes. And the moment I submit this task, it will go to this driver node, and then that transformation code will go to my machines. They will transform the code or transform the data, and then that data will come back to me. Wow. This is Spark architecture that I have explained you in very simple manner, because Spark architecture is something that you should be aware of. Not should be, you have to be aware of, because we cannot imagine data processing without Spark. Just tell me one organization which is not using Spark to transform the data, to process the data. Just tell me one organization. Because of its massive powers, we need to know about Spark. So this was the architecture of the Spark that I have tried to explain it in brief, it in very simple manner. Work is distributed among machines. Those are known as worker nodes. One machine within that whole cluster will manage everything, will orchestrate everything. Simple. So this was all about distributed computing with Spark. And that's how Spark processes our data so fast. Just imagine, bro, just imagine. You just sent your data to a machine which is managing so many machines, and your data will be processed by multiple machines together. Just imagine that your professor just gave you some assignment, and instead of you doing an assignment, you have told your friends to complete it, and you have divided that assignment in pieces. Now your 10 or 20 friends are doing that assignment. Just imagine the capability of that group has to deliver the task, and just imagine the speed. That's all about Spark architecture. That's how Spark actually functions. That's how Spark actually transforms the data for us. So that was all about Spark architecture. Now let's cover our favorite topic of the day: cloud data engineering. What if I tell you that 90% of the data are being stored in cloud nowadays? Only sensitive data is being stored on on-premise. Why? Because cloud storage is inexpensive, and cloud storage, bro, we do not even know cloud and you're talking about cloud storage. What you're doing, bro? Okay, sorry. Let me first tell you what is a cloud. What is a cloud? Cloud is basically that you can see in the sky. So basically, jokes apart, first of all, let me tell you the three big players in the cloud domain. Then I will just tell you what is cloud or what is cloud computing. So these three are the biggest players. Azure, which is owned by Microsoft; AWS, owned by Amazon; GCP, owned by Google. So Azure by Microsoft, AWS, that means Amazon Web Services by Amazon, GCP means Google Cloud Platform by Google. So these are three big players of cloud. Okay, bro, we know three big players. Now just tell us what is cloud and what is cloud computing. Otherwise, we cannot understand the further topics in this video. Okay, no worries, no worries. What is cloud computing? What is cloud computing? What is cloud? So basically, cloud computing means, let me explain you using an example. You as an organization, let's say this is your company, right? This is your company. Okay, let's draw it here. This is your company. Okay, in this company, you need maybe 100 computers. Obviously, you can expect these much of computers. 100 computers. Wow. You need 100 computers. 100 computers means 100 processors, 100 CPUs in layman language. Then you need, let's say, 8 GB of RAM in every computer, and let's say 1 TB of storage in every computer. This will cost you so much. And it can be the scenario where you will not be using 100 computers all the time, right? You might be using just 40, 50. Sometimes you will be using 80, 90. Sometimes you need to use 150. So you need to rush to the market to buy 50 more computers. And is it easy? No, no, not at all. Not at all. So what's the solution for this then? Because obviously we need to use computers. Solution is given by cloud providers. So here comes Azure in the picture. What Azure will say, it will say, bro, I have thousands of computers. Let's say it has thousands of computers. Let me write it here. I'm explaining this concept in a very simple way, and definitely you will master this concept. Just be focused. Just be focused. Otherwise, this concept is a really, really complex one. So let's suppose Azure has 1,000 computers, 1,000 PCs. Azure is saying, bro, instead of you going to purchase 100 computers where you will be using less than 100 computers most of the times, and at the same time, not times, at the same time, you will be using 150 computers, maybe 200 computers as well. Do you want an example? Maybe during a festive season, you can use like many resources, right? So Azure is saying, I have 1,000 PCs. What you can do, you can rent those PCs from me, and I will only charge for those PCs which you will be using. If you use 80, then I will just charge you for 80 PCs. If you want 200 pieces urgently, I have 1,000 of pieces. I can give you like this. I can give you 200 PCs as well within just few minutes, instead of rushing back to the market and purchasing it, because it has thousands of PCs and originally it has lakhs and crores. So do not worry about that. Just taking an example of 1,000 PCs. So it is saying I can also give you 200 pieces in just few minutes. In return, I just want to charge you as rent. Like I will just ask you to pay me the rent, because you do not own that PCs. I own the PCs, but your system, your design, your storage, your data is 100% secured. Like in reality, it is 99.95%, but let's say it's close to 100%. Your data is 99.95, or let's say 100% secured. I am assuring you that your data is secured. I am taking care of all the security of the data. So can you do this deal with me? Obviously yes. Obviously yes. So this is all about cloud computing, where you use all the computational resources through a cloud provider using internet. You do not need to own these things. Wow. That's why we are using cloud nowadays, because data is cheap. We do not need to handle the data. We do not need to take care of security of the data. Plus, we can scale our resources whenever we want. We do not need to keep the stock of PCs into our maybe warehouses, into our storage rooms. No, we do not need to worry about it. Cloud will be taking care of it, and we will just pay for the resources we are using. Let's say we are just using 1,000 TB, 1,000 terabytes. We will just be paying for it, and cloud storage is really, really cheap. Because just tell me the reason. Just tell me the reason. I have told you why it is so cheap. The reason is, yep, data lake. Because most of the times we as data engineers use data lake. We do have SQL databases, cloud databases, yes, but I'm just talking about from the big data perspective. We have data lakes. I hope this cloud computing concept is 101% clear to you, because this was the easiest example I could have taken. So after cloud computing, let me show you one important thing, and for that we need to go on Databricks learning page, because I have very special thing to show you, because this is recently added and this is a hot topic that you can expect in your interviews. And it's not just about interviews, this is very important fundamental topic. Let's see what's that. So I was talking about Medallion architecture. What is this? Ansh, bro, man, what you are doing, bro? What is this architecture now? Wait. Let me have some shake. So the thing is, this is a kind of data architecture that we currently follow. And this is a new addition to the world of data engineering. Not new, but relatively new if I compare with different technologies or terminologies that we used to use. What is Medallion architecture? Have you ever seen medals? Bronze, silver, gold? Yes, it is exactly same as that one. So why do we use it in our data domain or data engineering domain? Because of its robustness. Yes. So the thing is, let me show you first. So this is our Medallion architecture, and this is beautifully explained by this Databricks learning page. So let's say this is our data. This is batch data, this is streaming data. Batch data means when we have data in pieces, streaming data that we have real-time data that is flowing continuously. Simple. So what we do, do you remember that we talked about staging layer? It is somewhere similar to that thing. So we follow this Medallion architecture in cloud data engineering. So we first create bronze layer, which is also known as raw layer. But we are talking about Medallion architecture, so we will use terms such as bronze, silver, and gold. So in bronze, we push our data as it is from our source without any changes, without any transformation. This is the rule number one. We will not we will not make any changes. Any changes means any changes. So I should write it here. No change. Wow, my handwriting is really good, man. No change. So without any change, we pushed our data to bronze. Then we apply transformation, cleaning, aggregations, everything here in the silver layer. Like aggregations means when we need to clean our data, those aggregations, not business aggregations. So do not get confused. For simpler terms, let's say transformation or clean, like data cleaning, that's it. So this is our silver layer where we change our data, where we made transformations. Transformed. Oops. Transformed. Simple. Once the data is transformed, we push this data to gold layer. Yes, and in this layer we have data stored in the form of facts and dimensions, or maybe aggregated tables that depend upon the requirements. So this is our gold layer. Now if I just zoom it a little bit to show you, oops, this is also known as landing zone. See, landing zone for raw data. No change, no schema needed, nothing. Then we define structure, we enforce schema, we evolve schema as needed. What is evolve schema? Do not worry about that. But still, if you want to know, basically, we are living in an era where columns can be added, where schema can be changed. So if we want to evolve that schema, we do that same thing in silver zone. Do not worry about that thing. We will discuss it in future. Don't worry. So we do all the transformation in silver layer. Then we define data. data model for our downstream. See, we have a word downstream here. I told you that's very popular term. Downstream users and applications, right? So this is the Medallion architecture, and that's why we call it as bronze, silver, and gold. These are the kinds of medals that we use, that we have like in any games, or where we just define the layers, where we define the levels. And you can also relate it with the cleanliness of the data. In the raw layer, in the bronze layer, it is not cleaned, zero. In the transform layer, it is cleaned, but it is not ready to be served. In the gold layer, it is gold, you can serve it. Simple. So this is the Medallion architecture, and now it's time to, wait. We do apply Medallion architecture in our cloud data engineering architecture. What did I say? When we create the data engineering, cloud data engineering architecture, we use this practice, we use Medallion architecture to travel our data. So let's say this is our data. It is here, then it will go here, then it will go here, then it will go here, and this data will be consumed by data scientist and data analyst. Simple. We apply this strategy in building our end-to-end complete cloud data engineering architecture. Are you excited to have a look how end-to-end cloud data engineering architecture looks like? So I have a surprise for you. I have covered that as well, for just for you. So the thing is, we have three big players: Azure, GCP, AWS. Just repeat: Azure, GCP, and AWS. So if you master any cloud, I'm not talking about Azure, GCP, or AWS, any cloud, it is very easy for you to migrate to any new cloud platform, because some companies are using Azure, some are using AWS, some are using Azure. So it is very difficult for you to learn all the cloud platforms in your initial days. So the best practice is just focus on any one cloud platform and then master it. Then you can easily switch. How is it so easy to switch? Because all the services are same, exact same. It is just the renaming of the services. Just an example. If we are using data lake with names such as Azure Data Lake Storage Gen 2 in Azure, it will be called as S3 in AWS, and in GCP I think it's called Google Cloud Storage. I have not worked with GCP. So in GCP it is known as Google Cloud Storage. It is just the renaming of the thing. You do not need to worry about the skills that you, okay, you will feel like, hey, I'm just only learning one. No, bro, you just need to learn one. You just need to learn one cloud. Here comes my recommendation. My recommendation to you would be learn Azure. There are two reasons. Okay, tell us both the reasons. Okay, let me tell both the reasons. First reason is Azure is in demand. Azure is growing and beating all the other cloud platforms. You can check the graph online. I'm not just lying to you. You can check the growth of Azure, and I can see a solid future of Azure after the launch of Microsoft Fabric. Just trust me. Second reason, Azure gives you the opportunity to grab free Azure account, and it gives you 200 US dollars as well to spend it in first 30 days. And you can obviously use all the services that you want to use under that amount. An amount is like 200 US dollars, and you can easily create so many resources of Azure using that amount, and obviously it is free. If you want, I can just show you how you can create free Azure account, and you can just get started with it. And do not worry, I will just show you at the end of the video. And what's next after this? As I promised, as I just mentioned, that I will show you end-to-end cloud data engineering architecture. And now I am going to refer one cloud, that is Azure. So let's see how end-to-end Azure data engineering using cloud looks like. Are you excited? I am really excited to show you. Let's see. So this is the cloud data engineering end-to-end architecture. Whoa! We feel so overwhelmed right now after viewing this. I used to think like this few years back when I saw this picture for the first time. So first of all, I have taken this architecture from Microsoft Azure learning page. So what are these symbols? We do not know anything, first of all. And what are these numbers? We have zero knowledge. We do not know what's going on. So just explain the concept to us right now. That's why I am here. So I'll be explaining each and everything. What if I tell you in just few minutes, you will be aware of each and every single technology written here. What if I just do this? Okay? Promise, 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 promise. It's my promise to you. So just after a few minutes, you will be aware of all the technologies. So what I will do right now, I will give you a breakdown of all the technologies that we have in Azure, and then we will just revisit this architecture and just comment down the difference. Like once you saw this image for the first time and after I explain the concepts to you, just tell me the difference. Just tell me the difference in the comments. So without wasting any time, let's get started with the cloud technologies or tools that we have, so that I can just demonstrate what technology is responsible for what purpose or what task. So let's see. First of all, we have data streaming source. Okay, that looks cool, but what's that? So first of all, let me tell you the name of it. It's called oops. No, it's not called oops. It's Azure Events Hub. Yes, it's Azure Events Hub. It's called Azure Events Hub. What it does? So basically, if you have your streaming data means, let's say you have a source which is continuously giving the data, tuck, 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 continuously. So we have this service where you can store all this continuous data here in the Azure Events Hub. Wow. Wow. So that we can use real-time analytics on top of this data stored in Azure Events Hub. Is it cool? Yes, it is really cool. So whenever anyone asks you in Azure data engineering interviews or any interviews, which technology you should use for storing the streams, it's Azure Events Hub. So this was all about data streaming source. What's next? What do we have next? We have cloud SQL databases. Are you aware of normal SQL databases? Let's say you have it here, maybe SQL database, like normal one, like MySQL, or you can say you have here PostgreSQL. Let me write post. Just make notes. Just make notes. It is really important so that you can just try to condense the knowledge and you can easily relate it. So you have MySQL, you have PostgreSQL in cloud in Azure. We have something called Azure SQL DB. Yes, we have sweet name Azure SQL DB. So you can create your Azure SQL DB, like your SQL DB in Azure using this resource. Using this resource, simple, simple, simple. It is really, really helpful if you want to create OLTP databases in Azure. I'm really thirsty. I have been speaking non-stop. Whew, just for you. Just hit the subscribe button, like the video, comment, and just post it like anywhere you want so that everyone can be helped, because it's important to help others. So we understood this Azure SQL DB as well. And one quick question is, are the functionalities same? Yes, like you can perform everything that you were performing in MS SQL Server or anywhere else. So it is exactly same. You can run same SQL commands. Let's say someone will be asking, hey bro, can we just apply SQL statements? Yes, my answer is yes. You can apply everything that you want. You can apply, let's say, all the select functions. You can apply update. Oh, you can apply, let's say, delete. You can apply DDL commands. You can apply TCL commands. You can apply DCL commands. Anything you want to apply, you can apply in Azure SQL database as well. It is just same as your normal on-premise SQL database. Okay. Oh, we were waiting for it. I know you were waiting for it. Data lake. Okay. What is this data lake? Now we know what is this data lake. But what is the name of data lake in Azure? It is known as Azure Data Lake Storage Gen 2. Yes, we have this big name, but it is known as Azure Data Lake Storage Gen 2, ADLS Gen 2. So this does everything that obviously data lake does. So it stores structured, semi-structured, unstructured data. So basically, when we create storage account, what is a storage account? So basically, data lake comes under the storage account. So let's say this is your Azure. This is your Azure. So we create something called storage account. Okay, we create something called as storage account. Within that storage account, we get four services. One is this data lake. Okay, then we have something called tables, in which we store, let's say, NoSQL databases or NoSQL or key value pairs. Then we have file shares, where you can store everything under one roof. Do not need to worry because we do not use much. I'm just giving you an overview of storage account that we have, and under that storage account we have data lake. We do not have like direct resource in Azure. We have storage account. Within that storage account we have data lake, and there's like fourth thing as well. What was that? There's like one more. I can't remember the name right now. So there are basically four things that we get under the storage account, and main one is this one. This is the main one, data lake, and this is the data lake, and under this we get hierarchical namespace. Ooh, you have introduced a heavy word. Just explain us what's that. It's not heavy, bro. Let me just tell you. So it's called hierarchical namespace. What does it mean? Let's say so basically in data lake we have containers. We have something called containers. Now what are these containers? Containers are like folders. Like container one, that means folder one. Okay. So within that container, we can create sub-containers or sub-folders. Let's say I created one folder inside this, and one folder inside this, one folder inside this. Then you can create further folders as well. Let's say I want to create one more folder, or one more, one more, one more, one more. So you can create as many folders as you want within your container. You can create multiple folders. Are these really important? Yes. When you are working with big data, you would be saving this data, let's say, in multiple folders. So that's why it is really important to have hierarchical namespace. Yes. And this is the basically difference between data lake and blob storage as well. Do not worry about that. I'm just giving an overview of Azure services that we have. So if I talk about data lake, this is all about data lake in Azure. Then we have ETL tool. We love ETL tools. We have talked about ETL a lot, right? And ETL tool that we have in Azure is called Azure Data Factory. Whoa, this is really popular, I know. Azure Data Factory is basically an Azure ETL/ELT tool. So basically what it does, it helps us to extract the data. It helps us to move the data from here and there. It helps us to orchestrate everything. And you won't believe that everything we can do without any code. It is all code free. Like there is a little code, that's why it's called low code, not no code, but it is really simple. So let me give you a scenario where you have this resource. Let's say this is a kind of API. We want to fetch data. Now we know what is API. This is a kind of website where from where we need to just fetch the data. Azure Data Factory has so many connectors. You can easily connect this data with your API. And if you want to store this data, let's say in a data lake, okay, or maybe in SQL database, let me write SQL, you can do that anything you want using Azure Data Factory. Using Azure Data Factory, you can move data from one place to another. You can orchestrate all the tasks. It is a great tool, bro. It is a great tool. And just check the demand of Azure Data Factory in the market. You will get to know it is very much in demand. Azure Data Factory is very much in demand. You would be saying, bro, we also want to learn all these tools. Just be with me for a few more minutes because I have a surprise for you. Yes, I have a surprise for you. Just be with me and let me give you a hint. I will tell you that you can learn all these tools and technologies for free. Just be with me for like few more minutes. I will tell you each and everything. So what's next? What's after Azure Data Factory? We have Azure Databricks. Hey bro, we know about it because we saw it in the big data frames. Yes. So the thing is, when we want to process our data, when we want to transform our data, let's say, again, let's take a scenario that Azure Data Factory has dumped the data in data lake. Let's say this is our raw zone. This is our raw zone. Now we know the Medallion architecture as well. So this is our raw zone. It will take the data from raw zone. It will create the silver zone where data is transformed. And how it is transformed? Using Databricks, or you can say Azure Databricks. Yes, you can use Spark, Apache Spark, because Databricks acts as a uh, acts as a management layer. I'm really thirsty. That's why, like, I can't even speak. So it uses Spark clusters to process our data. So what's the difference, like, if it manages the Spark cluster? So the thing is, we do not need to take care of any clusters. We do not need to take care of worker nodes, driver node. No, everything will be taken care of Databricks. We just need to define the amount of computation we need. That's it. We just need to configure cluster. That's it. We do not need to manage it. So Databricks does everything for us, and that's why I love Databricks. Another tip, Databricks is in demand right now. Every company is looking for Databricks developers. Again, I will say, just be with me with this video for a few more minutes. You will get to know from where you can learn Databricks as well. Yes, just be with me. Just be with me. Okay. Then we have cloud data warehousing. Wow. If you remember, we showed Warescape Red in OLAP databases and we showed Snowflake. So Azure Synapse Analytics. This is called Azure Synapse Analytics. Let me write it for you. Azure Synapse Analytics. Oops. This is a cloud data warehousing solution. Yes, you can build data warehouses on cloud using this technology. So it is equivalent to Snowflake. Let me write it for you so that you can make notes. Snowflake, Redshift, or you can say GCP. And GCP we have BigQuery. Yeah, I have not worked with GCP much, so that's why BigQuery. So all are equivalent. All are equivalent. We have data warehousing solution in Azure known as Azure Synapse Analytics. Simple. You can build obviously fact and dimension. I told you that you can just build fact and dimension. This is your fact. This is your dim. Remember, this is your dim. You can create each and everything. I know. Now you will say, I also want to learn this one as well. Then I will say, bro, I have a solution for this as well. Now, what's the next one? Data reporting. After serving our data to data analyst, obviously they will be building reports. So here comes our Power BI. So in Microsoft or in Azure, we have Power BI as our reporting tool. And Azure gives you the best connectors with Power BI because the parent company is same. So that's why demand of Power BI is rising exponentially. And this is your reporting tool. You can just build your reports. Let's say you need to build dashboard or okay, let me give you an example, like end-to-end example, so that now you can relate. Let's say we have source. Let's say we have this source. Okay, this is our source. We use this resource or source. We apply ETL and we created facts and dimensions, right? This is gold layer. Okay, this is gold layer. Then this gold layer will be used by Power BI. It will use all the facts and dimension. Let's say in gold layer we have this star schema, this star schema. This will be used by Power BI to generate the report. Let's say in this report we have KPIs. Now what is KPIs? KPIs are like key performance indicators that help us how our business is doing. Is it growing? Do we have any losses? Or like all the information will be displayed here. Let's say we have 3 KPIs. We have pie chart. We have one line chart. And here is the manager who is using his phone to display, or sorry, to use this or to view this reports in its phone, because we have the capabilities to show the dashboards to mobile. And obviously if he is using laptop, obviously he can obviously use it on laptop as well. Let's say he is using laptop as well. Oh, I'm a great artist, man. So these reports can be consumed by the manager or maybe decision makers or maybe leaders. So this is the end-to-end task. Now, are you relating what you have done so far? You have started your journey from here, from source, from OLTP database. Let me write it here as well. Just draw this workflow for you, bro. Just draw this. This is your OLTP. Then this is your OLAP, right? And then this is consumed by Power BI, and then reports are here. This is your report. This is your report. And this is consumed by your this manager. This is the workflow of whole data journey, you can say. How was it? How was it? How was it? Now there's one more thing that is pending is let me show you this one. So as I promised that after a few minutes, you will feel much more relatable to this architecture. You will easily grab the information. So my recommendation to you, just forget about all the areas of this whole data architecture. I will walk you through step by step. Do not consider the steps mentioned in this data architecture. Just follow my steps. Just trust me, I will walk you through each and every resource, each and every activity which is being performed by Azure resources, Azure services. Let's get started. First of all, we have just discussed that Azure Event Hub acts as our data source. If we have data coming through streams, let's say real-time data, real-time data, real-time data, maybe through an IoT hub. IoT is like any kind of sensors, any kind of maybe digital thermostats which records the data for every second. So let's say we have here IoT hub. So it is sending streams to Azure Events Hub and it is storing that real-time data. Then we just discussed that Azure Data Factory is responsible for moving data from one place to another, right? So what it will be doing, it will pick the data from Azure Events Hub, okay, and it will push that data to our bronze layer. Now what is this bronze layer? Medallion architecture, we just discussed that our data gets traveled through three different layers: bronze, silver and gold. So this is bronze layer, so it will go to bronze layer as it is, no change. That is the rule number one, right? Okay. As you can see, we have Azure Data Lake Storage. So we will be using Data Lake Storage. And I told you that most of the times we work with Data Lake. Once data in bronze layer, it will be picked by Azure Databricks and it will apply Spark clusters. It will use Spark to transform that data and it will push that data to silver layer. Transform data. Yes. Now our data is transformed. It is residing in silver layer. Then what's next? The next step is sending this data to the gold layer. Yes, here. Just follow my steps. Do not get confused by looking at the numbers. That's why I told you, just trust me for a few more minutes. I will explain each and everything. It will go to the gold layer. It will go to the gold layer. And how? Obviously, we will be using Synapse Analytics for that to build facts and dimensions. Remember, we just build like fact, star schema, snowflake schema. So this is our star schema. So this will go to the gold layer. Once it is reached in the gold layer, we have two stakeholders. We have two downstreams. One is analytics, which uses Power BI. Second is data scientist. So for that, we will serve our data to this layer, to this complete layer, which includes Power BI for data analyst, for let's say data analysts. And what are these things? So basically, these are the resources that are used by data scientists. So you are not responsible for this. Data scientists will be using these resources. That's why I haven't covered these Azure resources. So this is data scientist, this is data analyst. So you have served your data to your downstream, right? Now everything is crystal clear. What is this thing? So basically it is very important to monitor the data. So that's why we have a resource called Azure Purview. It is a data governance tool available in Azure. Again, this will not be managed by you as a data engineer. It will be managed by a data governance team, but still you should know about data purview, data governance tool. Other than that, we use Azure DevOps. What is Azure DevOps? Azure DevOps is for CI/CD. What is CI/CD? So in the real world, you will be working in three different environments. Wow. Yes, dev, QA and prod. So CI/CD, Azure DevOps help us to promote our code to different environments. It is for deployment. Okay, what is this key vault? Key vault is used to store some secrets, some information that we cannot use openly. So we use Azure key vault. What is this Microsoft Entra ID? This is basically a service where we have a record of all the users within our organization using Azure. Bro, just make notes. Just write down all the things that I'm mentioning right now. Just make notes of everything. Then we have Azure Monitor. With this function, we can monitor the Azure portal, like what pipelines are running, is there any failure or anything else. Then obviously cost management, where we can just manage our bills, monthly bills. That was all about end-to-end cloud data engineering architecture. And now I know that you are really excited to actually learn these tools, because these tools are in demand. Azure data engineering position is very much in demand. So here's the surprise for you. As I mentioned, if you want to learn all these tools from scratch, I have created a dedicated video, and that video is like end-to-end data engineering project, and I have covered all these Azure services from scratch. And obviously you can create your Azure free account. I have shown how to create your free Azure account in that video. So that is your one-stop solution if you want to cover all these resources from scratch. So you can click on the video coming on your screen, and I will see you there. And before that, just a small request, just hit that subscribe button, because this will motivate me a lot to create more content like this in future, so that I can deliver the valuable skills for free. You do not need to pay for anything. So just click on this project video. I will see you there.